Section 8, Creating Functions. I'm gonna open in a new tab on the right here. I'm gonna create a new Jupyter notebook as usual. Section 8, Creating Functions Python3. This is overview. After the overview, then we got composing functions. Then we got tidying up. Then we got testing and documenting, defining defaults, readable functions, combining strings, return versus print, selecting characters from strings, rescaling an array, testing and documenting your function, defining defaults, variables inside and outside functions, mixing defaults and non-default parameters, the odd strict rule, readable code, and key point. So we got the key point here. Or capture it as usual. Get from the beginning here. So to define a function, we can use define function def, then the function name, then the parameter inside round brackets. The body of a function must be indented. We call the function just calling the name and the parameter. Numbers are stored as integers or floating point numbers. Variables defined within a function can only be seen and used within the body of the function. If a variable is not defined within the function, it is used. Python looks for a definition before the function call. We can use health thing to view health for something. Put docstrings in functions to provide health for that function. We can specify default values for parameters when defining a function using name is equal to value in the parameter list. Parameters can be passed by matching based on name, by position, or by omitting them, in which case the default value is used. We can put code whose parameters change frequently in a function, then call it with different parameter values to customize its behavior. So let's get back to overview. So the lesson is going to be about 30 minutes and the exercise 0 minutes. But I think it probably take longer than that. So let's see how it goes. We got some questions. How can I define a new function? What is the difference between defining and calling or using a function? What happens when I call a function? The objectives are to define a function that takes parameters, return a value from a function, test and debug a function, set default values for function parameters, explain why we divide programs into small single-purpose functions. So up to this point, we already learned about how to use loops to loop through all the files in one folder and also looping through all the elements in one file. We have learned how to use NumPy to import data into a NumPy array and calculate statistical analysis, basic ones. We learn about plotting. We already know how to plot single plot and multiple plot using subplots, and also we'll show you conditions like else to see the patterns and some unusual thing and issues in the data. But we got an issue is that the code is getting pretty long and more complicated, especially if we had thousands of data sets and we didn't want to generate a figure for every single one. So commenting out the figure drawing code is kind of nuisance. Also, what if we want to use that code again and again on a different data set or at a different point in our program? Cutting and pasting the code is going to make our code to be longer and more repetitive. So we need a way to package our code so that it is easier to reuse it, and Python and any other programming languages provide us a tool called functions. So function can be called as a shorthand way of re-executing longer pieces of code. So here let's start defining a function called var to Celsius to convert temperatures from Fahrenheit to Celsius. So here we got the function, and here's very good explanation of a function. So I'm gonna copy it because I like it so much and make it here. So we got def statement, which is how to define a function. Then here is the name of the function. Here are the parameters that we can put inside a function, inside the round brackets. And after that we got a colon at the end of the closing bracket. And now here we got a return statement, and inside here is the returning value. So again, to define a function, we just call the keyword def, put in the name of the function, put in the parameters that the function is going to be using, and the content of the function inside here. So we got the function, we run it, and let's try using it. So to use a function is very easy. We just put in the name of the function and the parameter, and we run it, and we got 0. So we can print this out. So the freezing point of water, which is 0 degree Celsius, and the boiling point of water, which is 100 degrees Celsius. Next, we're gonna look at composing functions. So we got a function converting from Fahrenheit to Celsius. Now we're gonna make another function converting backwards from Celsius to Fahrenheit. So I'm gonna copy this and paste in here. So we got the function name, the parameters, one parameter only, then the return, and the content is the return, and the computation inside the function, and we run it and we got the result. We can even make a function converting from Fahrenheit to Kelvin. So this is a function, and this is interesting because this function is using the other function that we just already created from the previous steps. So we can run that. So in order to run this function, we need to define this previous dependent two functions, and we got the result. Next is tidying up. So now we know a little bit of how to use functions, define function, and using function in functions. We can make our information analysis a bit easier to read and easier to reuse. So firstly, let's make a visualize functions that generate our plots. So this is a function. Firstly, I'm gonna define function and put in the name is visualize, and the input parameters is file name, and then we type colon at the end of the function. First step we need to do is we need to load data to a NumPy array. So get data is equal to np. So of course before this we need to import NumPy as np, import of course np, import matplotlib.pyplot, import matplotlib.pyplot as plot. Now we can use it here. So we got np.load.txt, and we got file name is equal to, and delimiter is equal to. So in the file name here we can put in file name, and that we got the data loading in. The second step we need to do is creating figure. width size. So we could figure is equal to mark. We can use plt dot figure, and then we got figure size in here. Or we just use this just figure size. It's gonna be a tuple 10 by 3 for example. And now we can create subplot. So inside subplots here we can put in axis 1 is figure dot add subplot 131. Can copy it and make it axis 2, axis 3. So this one should be 2, this one should be 3. We call axis 1 is set y label. Axis 1 set y label. We put that after creating the plot, we can tidy up the plot by figure type layout and then plot out the figure. So for now we just run the function, and we can use the function now. So we're gonna define file name is gonna be so we got file name, which is so we need to import globe as well from here. Import globe, and probably import os, import sys as well. So globe, we got globe and like that, but we want to os change directory to data, and then now we can print out the current working directory. What I'm doing, that's so weird. Print os.get current working directory. Yep, it should be inside a code. So I got file name here. File name, it's just file name and the first element. I'm gonna print out file name. So I got that file. Actually it's not working because we're still in there. So we need to change directory to data. Need to run this. So now we got the first file is that one. It's not reasonable. I think I need to change the file. This one need to be something W, because I want inflammation to be on top of the list. I'm gonna run it again. So it should be inflammation. So I got my file is inflammation01 CSV now. I'm gonna choose to run it using visualization function. Something not very good is loading the file. It's not working. Say load txt got an unexpected delimiter argument. So I'm gonna load data delimiter. I'm gonna run this again. So it's working now. So what happened to this? Delimiter. Okay. It should be I there. Okay, it's just a typing mistake. So I got that. I got the subplots, but I didn't plot data. So now I need to plot data. So in the order to plot data, I need to put in like subplot 1. Here is subplot 2, and here is subplot 3. Inside subplot 1, I'm gonna add in the add y label. It as the first one is as maybe the maximum, maybe can average, and then axis 1 is plot. We call np dot mean, and we put data in, and the axis should be 0. And we got that, and we do the same with this one and the same with this one. So tidy up the plot. Go show the plot, just simple like that. And this one should be maximum, this one should be minimum, and we got here is minimum, here is maximum. And again we change the define function, and now we can run the function. Somehow it's not working. The reason why is because add label is not working for an axis. Okay, so this should be 2, should be 3 there. That's interesting. So we don't have add y label, we have set. This is set y label. So we print it out. We still got arrow, which is axis 4 is not defined. So this is this one, but not a big deal. Axis 4 is not defined. Run it again. So it looks okay now. So the function is now working, and this is the file name 0 actually, and we got that for the file name 0. But if we got another file name here, the file name 1 is that, and we can visualize file name 1, and just very short script, because we use the function again, we get the similar result with very long script like previous section. So that is a benefit of using a function. Next, we can also create a function called detect problems. So here we got define function, we got detect problems, and we put in file name. And then similar, we're gonna got some steps inside the function. We got load data into np, and we got condition. Okay, so firstly we need to have data, which is numpy.load txt, load the file in, and when load in we need the file name, which is just file name, and the axis, which is always 0 for this case. Oh sorry, which is delimiter, which is comma, because data is CSV comma separated, and then we can play with some conditions. So we got if np.max data axis is equal to mark, the first value is 0, and numpy, no, it should be np.max data axis is equal to mark, no, 20 is 20. You're going to weird, the first element is 0 and the 20th element is 20. You're going to print out something called suspicious looking maxima. Similar, we got elf, so some elf if, so got np.sum, and in here is numpy.mean mean sub data axis is 0 is equal 0. So we got all the mean, or the sum of that is 0. We're gonna print it out, maximum add up to 0, and we got else, we got print now sim. Okay, so we got else if here, and we should put it inside in indentation. No, we should not have else if with that colon. Colon is should be at the end of else if. So the function is working, and we can test that function with file name 1, file name 0, suspicious looking maxima. So we print that out here, maxima looks suspicious. Yeah, and if we use with number 1, we also have suspicious looking maxima as well. Okay, however, we didn't put in any return for this function. So the function we just made, 2 of these functions are just printing out the result and didn't returning anything. So that's why in Python even we can return the result of the function into something, but we don't need to use it to define and to have a function. And even we can define a function without any parameters as well. Like we have the function called define print hello, and inside this function we just print hello world. We run that, and when we call this function, it don't have any parameter, but it's still running. With a function that don't have returning value or returning result, the purpose of some kind of function is just grouping together piece of code and saving typing for us. So now let's use the function that we just created, and let's reproduce the analysis that we had before, but in a shorter manner. So we got here, we got file name is this one, and then for file in file name, what we do, we will print out the file name, we print out the file, and we call the function. We have 2 functions, which is visualize and the file, and detect problems, and we put in the file and we run it. So you see that with very short scripts, but we got the whole result as last time, the whole analysis here. We got an issues here because inside data here we have nothing in this data file, because it's just an empty data file. So if we got this, just ignore it, but we got the other one here. All the inflammation data sets and small data set are reading and printing out. So we got all the detect problems result for every single file as well. Next is testing and documenting. So once we start putting things in functions so that we can reuse them, we need to start setting those functions to make sure that it's working correctly. So here's an example. We got offset mean data and target mean. So we got inputted data and target mean value. So it's gonna return data minus the one minus the mean data and plus target mean. We could test this out actually on our data, but since we don't know what the values out to be, it would be hard to tell if the result was correct or not. Instead, let's use NumPy to create a matrix of 0 and then offset its value to have a mean of value 3. So it's just an example of it. We got there Z is looking like this. Then we call the offset mean and we got the result like this. So now we can run the offset mean to our real data. So here we got data is I would call data 1 and then put the data 1 in here, and it's in data in my case. Actually we are in this folder, so it should be data. So if we're doing like this, we can see that the offset is 0. So that is the original data. So it's really hard to tell from the default output whether it is correct or not, but there are a few tests that we can run to reassure this. So we can do another kind of test here. What we do here, we're gonna print out all this kind of thing out. So we got the original mean here, and we got the after the offset. Something wrong because the data now is data 1. So offset data, yep, it should be data 1. Okay, so we can see here the original mean and max are this one, and the mean and the max of offset data are this one. So it seems almost right. So the original mean was about 6.1. So the lower bound from 0 is now minus 6.1. The mean of the offset data isn't quite 0. We'll explore why not in the challenges, but it's pretty close now. So we can even go further and check the standard deviation if it is changed or not. So we can print it out here. The standard deviation, put in here, we calculate the standard deviation for the data 1 and the offset as well. Before and after, we got that. It's the same. But we see that there's so many number after decimal points, so we want to do it a little bit different. Data 1. So now we can see the difference between the before and after is 0. So that means it doesn't change. I'm not sure. In this case, it's like for my result is 0, but for the computer result, provided result is very small. I'm not really sure, maybe because of Python version, when I'm running with my NumPy version, is providing me this result. So that's it for that part of the thing. The next thing we can do is we can put commands and documentation for our function. So the usual way to put documentation in software is to add commands like this. So we got a script like this. We can put in adding commands. So we add in is like, so something like that. So we know something about the code. But actually there's a better way to do that. We can put a string in the first part of the function, and that string is gonna be the documentation of the function, something like this. And that after the function is defined, we can call help, and we just use a function. We can help for whatever function, like sum. We got the built-in sum function, but we can also help for the new function that we just defined it. So we got here offset and all the description inside this string. So we have some idea about the function, and this is very useful practice and good practice to have some documentation for our function. So the documentation for a function can be called as a doc string as well. The reason why we use 3 quote here instead of like single quote or double quote, we use triple quote here. It's just because we can write multiple string between those 2 triple quotes. So like in this function, you can even write multiple lines inside here, multiple of them. So that is useful. Next is defining defaults for functions. So we have passed parameters to functions in 2 ways: directly, as in this example, or by using name, as in example. And actually, instead of using this, we can also run the function like this without that one. No, the delimiter maybe is important, but we even don't need to put in f name like that. So just put in the link to the location of the data file, and it's still working. So let's try that. For this one, we're gonna load that one and gonna use that file and see if it's working. Yeah, it's working. So that we don't need this one. We don't need to put f name is equal to. We can put it out. So it say typing, and also say us. If we forget the keyword, it make me better. So next is here. I don't know, the function got an error. Okay, so how about if I try this and I put the delimiter out, and I'm gonna get an error. So this is a syntax error, and it say unexpected EOF while passing. So basically it's require you to type in delimiter is equal to that. It's a must for the function. So it depends on the case we need to use this or not. We got another example to explain this. So let's say we have the function like that function. So we see here the key change is that the second parameter is now written. The target mean is equal to 0 instead of just target mean value. So if we call the function with 2 arguments, it works as it did before. So after we define the function, we can test for the first one here. So in this case, we put in the target mean value is 3 here, and the test data, we need to put in the test data. We got the test data as well, so we can run the function, and it's working like that. Now we got another example. We got more data and more data. So then we put in offset value, and we didn't set the second one, the second parameter, which is target mean value. And because we didn't set it, so now the target mean value is understand as 0. because it's the default value of target mean in the function when we define it. So if we run it, so you see here we got here is more data from the beginning, and after we run the function we got 0 because the target mean is 0. So this is handy if we usually want a function to work one way, but occasionally we need it to do something else. We can allow people to pass a parameter when they need to provide a default to make a normal case easier. So we got an example below show how Python matches values to parameters. So here we define a function called display with 3 input parameters, and they are all got default is 1, 2, 3. And after that we're gonna print out all the 3 parameters, and we run it. So if we don't put any parameter in, the function understand that it's gonna get the default parameter and print out. If we put only one parameter, the function is gonna get that is the first variable A, and then it's print out A is the input one, but the other one B and C is still the default one. Similar, if we put in 2 parameter, so it's automatically assigned to A and B, but C is still the default one because C is missing. So at this example, we see that parameters are matched up from the left to the right, and any parameter that is not given during running the function is gonna be automatically getting the default value for calculation. So we can of course override this behavior by naming the value as we pass in it. So like here, for example, if we here we call the function display and we put in 1, it's gonna understand that maybe 5. It's gonna understand that A is 5. But how about I want to put in one value for C only? So what I need to do, I need to put in C, and I put in 6 like that. So now it's gonna skip A and B for the new inputs and getting the default values, and C is gonna assign to 6 and print them out. So if we run this, it's gonna get the same result because we assign C to 77, and A and B is still the same as a default value. So with that in hand, we can have a look at the health of the numpy function, numpy.loadtxt function. When we run that, we can see inside here there are a lot of information, but actually the most important part is actually this very beginning of the function. So we see that we got load.txt, we got file name, we got data type, which is default at float, we got comment is that one, we got delimiter, which is default as none, we got converters is none, skip rows is 0, and the columns is none, unpack is false, ndmean is 0, and encoding it bytes. And you see that in this case we see we got a parameter called fname, and it doesn't have any default value. So when we run the function, we definitely need to put in that value. So when we call the function like this, and we got error as we experience here, we got error. So why we got error for this case? So let's have a look here. When we call the function like this, then the file name here is assigned to fname, which is good. However, the string here is not gonna assign to delimiter, but it is assigned to dtype because it's gonna assign to the second parameter of the function, and that is not expected by the function, and then it's gonna throw out the error. So that's very easy. So instead of doing like that, we need to explicitly specify delimiter is comma, So we can run like that here as this example, and it's working for us. So that is a explanation of why this is, when we run like this, we got error, but we run like this, we didn't get any error. Next is readable functions. So we consider these two functions. So we got the first function here, and we got the second function here. So here the function adds and the function standard deviation. So actually they are both using to calculate standard deviation, but you see that to a human reader it looks different. So you can probably found that this function is easier to read and understand than the first function. Why is that? Because the function name is more meaningful, the variable name is more meaningful, and the input parameters is also more meaningful. Combining strings. So we somehow know that adding two strings can produce their concatenation. So when we add A and B, we're gonna get AB like this, A plus B, you're gonna get AB like that. So here is actually a challenge. We need to write a function that called fence that. So we need to define a function called fence, and that takes two parameters called original and wrapper, and it's gonna return a new string that has the wrapper character at the beginning and end of the original. So it just wrapper plus original and wrapper. That's what I think. And then a code to your function should look like this. When you print the function out, you're gonna get that. So let's try it, and I got that, and the solution is exactly what it is. Next we have another challenge. Note that we got return and print are not interchangeable. Print is a Python function that prints data to the screen. It enables us as a user to see the data, but return statement on the other hand makes data visible to the program. So let's have a look at the following function. We define a function called add, have two parameters A and B, and then we will print out A and plus B. So we got a question: what will we see if we execute the following commands? So we got A is add 7 and 3. We can print it out there. So now we've got A is that, and we print A out. We got that one. But so the question is that, and the answer is we don't have anything. We don't get anything. We print I, we don't get anything. It return none, but actually if we run in a Python environment, different Python environment, it actually print out anything. So result is here. The solution is Python will first execute the function add. However, the function doesn't return anything. So we just print out A and B here, but it didn't return anything. So this is important when we use that function as a result. So if we assign A, we assign the result is print A. Now it's add 7 and 3. We run that. So if we run this, it seems that it returns result, but actually it's not. It is printing out result. And then we call the variable result again. We got nothing. Why? And if we print out result, we got none or nothing. Why? Because it's nothing inside the result, because the function didn't return anything. So instead of doing that, now if we change the function add again with return, and at the end of the function we make return A plus B, and now we don't need to print it out like that. So now if I got result here, result 2 is add return 7 and 3. Now I print, okay, I run that. Now I call the result 2 I got 10. But when I run this, I also got 10, but actually this is returning 10, this is not printing 10 out. So it's confusing a bit, but you need to do that. You need to recognize and differentiate that. We got another challenge, which is selecting characters from string. So here we got if the variable s refer to a string, then s0 is the first character and s-1 is the last character of that string. Okay, so write a function called outer. So I'm going to define a function called outer, and that function will got a string in. That function will return a string made up of just the first and the last characters of the input string. So I'm going to return and just, I think, string the first character concatenate with string the last character. And when I run this, I should get yeah, and the solution should be the same. Next, we got another challenge, is rescaling an array. So we need to write a function called rescale, takes an array as input and return a corresponding array of values. So input array, and it return a corresponding array of value scale to lie in the range of 0 to 1. We have a hint here. If L and H are the lowest and the highest value in the original array, then the replacement for V should be that. Okay, it's pretty challenging. So I'm gonna, instead of doing that, make it easier for me, I'm gonna make it return new array. And here we call new array is equal to. So let's say we got an input array, and the formula is that the new array is gonna be just a new array divided by just the input array, I think so. Just put the input array in, minus for the lowest, that means np.min of the input array. Okay, and then down there is gonna be np.max of input array minus by np.min of input array. So I don't like input array because it make my code longer, so I put in array like that, maybe making like that. So I just change input array by that, so it make my code shorter, easier to read. I can even change this by new array like that, so it make the parameter or variable name shorter. So it's a good practice when we do coding. And that's the function. I think we don't have any example. Let's say you got an array called or something, maybe input array, which is np array, and in here we put in a list of maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it takes an array input and return corresponding array values scale to lie in the range of 0 and 1. That's pretty challenging, as the lowest and the highest value in the original array. Let's think about that. It's kind of normalizing. So this is rescaling, is kind of normalizing calculation or normalizing analysis. I think it should be working fine. So let's try it. Yep, let's try it. Let's rescale that one. Of course, we print now. That's interesting. So how about we want to rescale to like 1 and 255, which is similar to image processing. How about that? So let's say we define a rescale function here, and instead of putting there, I think I'm gonna how to rescale to 255. This is challenging. So it needs to make it the smallest one is 0 and the biggest one is 255. So here the biggest one, I think just multiply with 256. Yeah, so just that, and instead of that one is 2, so multiply with 255. And then we put the other example, which is more random, like 2, 3, 4, which is minus 36, which is 394, and we run it and we see that we got pretty good, but maybe we can change the rank it better. Instead of doing that, we can like 10, 20, 30, 40, no, maybe 30, 60, or maybe no, 0, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800. And now we got, yeah, so the rank is more than 255, but now we rescale it to be like that. I think that's good. It's very nice. So that is normalization computation. That's very used in, I think, image processing. Okay, that's my solution. Let's see the provided solution. So we got L is mean, H is the max. That's good. That's good practice. And we just put in that formula. Yeah, I love it. Very clear. So it's good practice to slice the code smaller and then reuse the variable. It's very easy to read and understandable. Next, we got testing and documenting your function. Run the command health numpy range. Yep, I run that. And numpy linspace. Run that as well to see how to use these functions to generate regular space values. Then use those values to test your rescale function. Once you successfully test your function, add a docstring that explains what it does. Ooh, okay. So you numpy array. So based on the health, we can see that numpy arrange, which is from start, can be for example maybe just -5, and stop is 1000. Then the step is probably getting maybe 40, and I got that. So that is numpy arrange. The other function is numpy.linspace. So I got start similar 5, stop, which is 1000, but here we got num. So num here is optional and it's not the step. Num here now. Oh, so it's similar to numpy arrange. So here the step, which is the spacing between values. It makes sense, but for linspace, num here is not spacing, but it's actually the number of samples to generate. So we want to generate 9. So I want to count for this length, which is 26. So I can put in 26. You see that we can use different way of generating random number between a range, using the step or using number of sample. So that is the health of two function. So I can close it down. So the next thing I'm gonna do is I'm gonna use my new rescale here. I put it down there, which is rescale 250. So I like that function, and I'm just gonna run that with the new generated data. So I'm gonna put this inside, and I got that from 0 to 255. And if I use linspace, so rescale 255, I got that. But if I want to use the rescale as the provided function here, maybe I call it rescale 1 to be interesting, and I can run that here. I got from 0 to 1. Is that correct? No, should be 1 here. And I run this, and I got the same. 1 there, from 0 to 1. And the challenge also require me to put in some doc string for my function. So for example, this one I can put in some doc string here. So I'll return what? Return the rescale input array into new scale between 0 and 1. That this function, and the other function is gonna be 20 and 255. So now I run both of them, and if I do health, the rescale function 1, I got this. And similar, I do the health rescale 255, I got that. So result is here. Take an array as input and return a corresponding array, so that 0 corresponding to the minimum and 1 is corresponding to the input array. So here's the example numpy array rescale that one. So I'm gonna run that. This is for rescale 1, and I'm gonna run that for rescale 255. Got different scale. It's similar to my solution. Next is defining defaults. Got another challenge. Rewrite the rescale function so that it scales data to line between 0 and 1 by default, but it will allow the caller to specify lower and upper bounds if they want. Compare to your implementation to your neighbors, and do the two functions always behave the same way. Okay, so I'm gonna rewrite the function here based on that function, and between low and high, and low and high is input input parameters. So we're gonna got low and high here. Yep. In low, let's say that in high. So instead of calculating that, we're gonna got in low and in high is different now. So it's kind of challenging. How about in low and in high now is, so I mean just low and high, and then comments this out, just delete this out, and I'm gonna run that for this one. Now maybe rescale is rescale 2. Run that. It's not working because we need to input L and H, so it should be maybe 0 and 1. Okay, with return, no, it's not what I'm looking for. I don't think that's what I'm looking for. This doesn't return 0 and 1. So how to make it returning 0 and 1? Okay. Input the array minus L and there. So this is always 1 there. A bit challenging. I don't think it's simple like that. I'm gonna get it back to that. I think we still need in and out, and we still need to calculate this min and max because we need to rescale it. But after we need to be calculated array, so we can put it as it's gonna be this one, yeah. And now the output array is gonna be that one, and we're gonna plot. Gonna get that. No, the output array is gonna be the minimum is that range, and we're gonna just that in I think calculated one, and we just multiply by the maximum minus the minimum. So how can I scale to that? Let's have a look. So let's say the function is 2. We got the inbounds and outbound, the lower bounds and the higher bound. We continue to calculate the minimum and the maximum, and the calculated is similar, should be that one. So I mean this one should be 0, 2, 1, 0, 2, 1 array, and then here is our array. So our array is gonna be 0 to 1 array, and it's gonna be just lower inbound plus the 0 array, which is from 0 to 1, and this is higher minus 1. So just in case this 0 to 1 array is 1, then we got inbound plus 1 multiplied by low value plus 1 multiplied by high minus low, and then we just have high value, and then exactly the bounds. And if this is 0, then this one is 0, and then we got the lower bound, and we got the output array. So we should run that, and we run this. So we got the bounds now is 0 to 1. So how about we want like 5 to 15? We got different bounds and we got different results. So it should be pretty much what we got here. So let's see the solution. So we got here rescale input array, low value, high value. Rescale input array values to lie between low value and high value. Just run it again. So I'm gonna run that. So see that we got that, and the intermediate array we call 0 to 1 array is this one, and then the output array is gonna be this one. It's similar to what we got here. Next is variables inside and outside functions. We got another challenge. What does the following piece of code display when run and why? So we have f is 0, k is 0. We define a function called f to k, which is f is the input, and then we have k is calculation based on f, and then we return k. So when k is 0, this one is 0, and it should be this value. So if I calculate it out, it's gonna be something like that. Something wrong. Yeah, should be 250, something like that. If I print out the k, of course k is always 0. Yeah, k is always 0 in this case. So of course k is always 0. So k is 0 because the k inside the function doesn't know about the k defined outside the function. Yeah, that makes sense. So next is missing default and non-default parameters. So we got the following code. We got this code, enter it, and it's wrong. We got an error, non-default argument follows default argument. Okay, so we got this is non-default argument, and then we got the default argument, and then a non-default argument, and we got a default argument. So we got a question, what do you expect will be print out? This one or an error? Yeah, I print it and I got an error, which is syntax error. So why is that? So given that, what does the following piece of code display when we run? So here we got function. We define a new function called func. The input parameters is a, b, and c. With bc is default and a is not default, and we just print out abc, and we call the function f minus 1 and a minus 1 and 2. I think it's gonna be printing out this one. I guess so. It should be 3c, so it should be this one. So let's run the function and see if it's working like that. Yeah, so it should be this one, number 3. A is minus 1, b is 2, and c is 6. So when we got this issue, we remember that to run this is not working. So in order to run that, we need to define 1 there. I think 3 is gonna be something. Let's try it together. Not working as well. So we need to define something like 1 is 1, then we got 2 is that, we got 1 is 1, and 3 is 3, and it's not working as well. Okay, this is not defined. We're gonna define again, run that. Number is not defined. Define it again here. What happened? Non-default argument follows by default argument. Okay, sorry. So if we define a function like this, it's not gonna allow us to define a function. So the default function need to be after a non-default function in order to make the function is running. So I make it again here. In order to run that, I need to make this like this one, that, and we make this is 3. this is 2. Then now we can define 2 here, and now it's working. But if we make 1 is 1, we can see that it's not working because we cannot make a parameter which is a non-default parameter after a parameter which is a default parameter. So all the non-default parameter need to be from start, and the default parameter need to be later. Okay, so that's it for that. We're going to the next part is switcher row. So we consider this code. Okay, so we got which of the following would be printed if you run this code. Why did you pick this answer? So let's say I got A is 3, B is 7. We got define a function called swap, get 2 parameters as input. Temp is A, then A is B, and then B is temp. Okay, so we run swap. Now we're gonna get 7 and 3, so it should be 7 and 3 because now B is getting as A and A is getting it B. Run that. I'm wrong. Actually, I'm wrong. Why is that? So A is that one, and I print that out, and it's still getting that. This is really confusing. Really confused. So let's print it out to see how it works. I'm gonna print temp. Then after that I got A, I'm going to print A. So here I'm going to print A outside. Yeah, and I'm going to print here is B outside. So I get that. I'm going to print temp, I'm going to print A, and I'm going to print out B, and I run the swap function. Okay, so this is A outside, I got 3, B outside, I got 7, and that's good. So inside function here, when I run it, I got temp is 3, which is A. Then A is assigned to B, which is 7. Then which is 7. Okay, so I can put in a little bit more information, which is temp, which is A, which is B, and that. So we run the function and we got A, B is inside the function, but A and B outside is still the same. So the function actually didn't return anything. The function is just, define new variable, then assign new variable, and it's kind of local variable, and those variable it just exists within or inside this function. It's not outside. So A here is different from this A, and B here is different from this B. And when we call print out, actually we call print out this B. So we didn't reassign A and B because it's actually local variable. Not really, because we choose A and B. It's interesting to me. Yeah, so let's see how the solution is working. But in order to analyze the loop and then running it, you can put the print out like that. So you can even print something else like this. Print 50 multiplied by that. So you got that. This outside is inside, and a bit more easy to see. So let's see the solution. So we got 3 and 7 is the correct answer. Why? Because initially A has a value of 3 and B has a value of 7. When we swap the function is called, it creates a local variable called A and B in this case, and trades the values. The function doesn't return any value. Yeah, that's good. And does not alter A and B outside of its local copy. That's good. Therefore, the original A and B remain unchanged. So that's reasonable. So it doesn't return anything. So it doesn't change. And this variable is actually local variable. So this is a very example of local and global variable. So next part is readable code. So revise the function you wrote for one of the previous exercise to try to make code more readable. Then collaborate with one of your neighbors to critique each other's functions and discuss how your function implementation could be further improved to make them more readable. So that's it, and here are the key points so we can quickly review it. We can define a function using that way to the body of the function must be indented like that. This is indented. We call a function using that way. Numbers are stored as integers and floating point numbers. Variables defined within a function can only be seen and used within the body of the function. So this is a very good example of that. If a variable is not defined within the function it is used, Python looks for a definition before the function is called. Use health thing to view health for something. We can put docstrings in a function to provide health for that function. We can specify default values for parameters when defining a function using name is value in the input parameter lists. Parameters can be passed by matching based on name, by position, or by omitting them, in which case the default value is used. We put code whose parameter change frequently in a function, then call it with different parameter values to customize its behavior. So that's this for this section, creating functions. So I'm going to close that, and get back to the main table of content. The next section, section 9, we're going to look at errors and exceptions.